All right, so this is the Algebra 2 Trig test review. We're going to quickly go over here. So I've already filled out the unit circle, and you should have to before you actually tackle this part of the test review, because that's going to make a lot of these questions really quick. Remember that the sine trig function goes with the y-coordinate, cosine goes with the x-coordinate, and tangent, of course, is y divided by x. So the first angle is 210 degrees. So we're going to look on our unit circle, and we're going to find 210 degrees right here. And we've got our x-coordinate, so this is going to be our cosine value. And we've got our y-coordinate, so this is going to be our sine value. So there's the cosine of 210 and the sine of 210. And remember, we can easily check this on a calculator. Make sure we're in degree mode. When we type in the cosine of 210 degrees, we're going to get a decimal, which remember is not the answer, but we can type in the answer, which was negative square root of 3 over 2, and we should get that exact same decimal. Remember how to type it the first time, but negative 0.866. So that's a quick way to check your work. And of course, the sine of 210 is even easier because we get negative 0.5, and of course, that's equivalent to negative 1/2. And then finally, the tangent of 210 is the y-coordinate divided by the x-coordinate. So we have to do a little bit of math here, but it's just going to be negative 1/2 divided by negative radical 3 over 2. And we're going to multiply by the reciprocal to simplify this. So we're going to take the top fraction and multiply it by the reciprocal of the bottom. So we multiply across the top, we get positive 2. We multiply across the bottom, we get positive 2 radical 3. 2's cross out. And then we're going to rationalize the denominator by multiplying bottom and top by radical 3. So we get radical 3 over 3. I'm going to erase all this work in just a second. So you probably want to do some of this work on a separate sheet of paper, unless you can write a little bit smaller. The same thing with the tangent of 210. We can type that tangent of 210 in the calculator, and it's going to give us a nasty decimal. But radical 3 over 3 should give us that same nasty decimal. So we know we've done it correctly. I'd encourage you to try number 2. I'm not going to go through each step. I'm going to show you the answer here in about 5 seconds. So pause the video if you need to. So here's the work on number 2. Again, cosine, you're just looking for the x-coordinate at positive 135. Sine's the y-coordinate, and tangent is y divided by x. So that's why tangent of 135 is negative 1. Let's real quickly do one that's in radians. You should have already converted 5 pi over 3 2 degrees in your unit circle. And you'll notice 5 pi over 3 is equivalent to 300 degrees. So this is where we're going to get the cosine value, because cosine goes with x. This is where we're going to get the sine value, because sine goes with y. So there's cosine and sine. And again, for tangent, we've got a little bit more work. We've got to take the y-coordinate and divide it by the x-coordinate. And we're going to multiply the top fraction by the reciprocal of the bottom. Multiply across the top, we get negative 2 radical 3. Multiply across the bottom, you get positive 2. Negative 2 over 2 cancels out and becomes just a negative 1. So the answer to the tangent problem, kind of out of space here, so I'm going to write it over here, is negative radical 3. Remember, if you want to put these in your calculator to check, you do need to be in radian mode. So like when we type in the cosine of 5 pi over 3, that's a radian. You get 0.5, and of course, cosine of 5 pi over 3 is 1/2. So make sure you go back from radian to degree to check these. But that's the only reason you're using the calculator is to check these answers. All right, and then I'll get started on number 4. Number 4 is negative 45 degrees. So we need to go to the unit circle. And since it's a negative angle, we're going to go clockwise, or we're going to go down 45 degrees until we stop at 315. So I'm going to cross this out and change it to 315 to do sine, cosine, and tangent of that number. And again, you'll notice 315 plus 45 gives you 360. Anytime you have a negative angle, those two coterminal angles are going to add up to 360. So pause the video if you like, if you want to try this on your own. I'm going to give you the answers here in about 5 seconds. So there's the answer to number 4. Of course, tangent is y divided by x, so we got negative 1. Since y and x were the same number, just one of them was a negative. 495. So that's obviously not on the unit circle. It's over 360. So what I would do is I would subtract 360 from this number, and that's going to give us 135, which does show up on the unit circle. So since the unit circle just repeats itself over and over again, we can mark out 495 and replace it with 135 and do all of our calculations for that angle on the unit circle. So find 135 degrees right here, and that's where you're going to get your x and your y coordinate. So here's the answers. They're a little bit hard to read, but cosine should be negative radical 2 over 2. So basically, cosine and sine have just flip-flopped. Since we're in quadrant number 2, x is negative, y is positive, tangent is still negative 1. So go ahead and try the last one, number 6. I'll show the answer here in a second. 5 pi over 6, that should be on the unit circle. If it's not, convert it to degrees first. All right, so there are the answers to number 6. Number 7, which expression is not equivalent to the cosine of pi over 4? Well, let's figure out what the cosine of pi over 4 is by looking at our unit circle. Pi over 4 is right here. There's a horrible line drawn, but we're looking at the x-coordinate. So cosine of pi over 4 is positive radical 2 over 2. We're looking for the one that is not equivalent to that. Well, the cosine of 45 degrees, if we look on the unit circle, is the exact same thing as pi over 4, just converted to degrees. So we know that this one is also going to be radical 2 over 2. So that's not our answer. The sine of 3 pi over 4. So find 3 pi over 4 on your unit circle. It is right here. But this time we're talking about sine, so that's the y coordinate. And the y coordinate of 3 pi over 4 is radical 2 over 2. So it's not A, it's not B. Let's check D, sine of 225 degrees. So 225 degrees is in the third quadrant. And of course, sine is negative in this quadrant. So it's a negative radical 2 over 2. So that is not exactly the same. So the answer is D. Now you notice we skipped C because C, 9 pi over 4, you'll notice that is not on the unit circle. If you convert 9 pi over 4 to degrees, it's the same thing as the cosine of 405 degrees. Let me write a little arrow out. Which is basically 360 plus 45. So the cosine of 9, excuse me, the cosine of 9 pi over 4 is the same thing as the cosine of pi over 4. So it's also going to be radical 2 over 2. But you had to convert that one to degrees probably to see that. Number 8 is just a thinking question. It's saying the cosine of some angle equals negative 1/2 in the second quadrant. So basically we're just looking for where is x equal to negative 1/2 in the second quadrant, at what angle? So let's look here. In the second quadrant, x is negative 1/2 right here at 120 degrees. So that tells us that this x right here, this unknown, it probably should be using theta instead of x, but this unknown is 120 degrees. So that means what is the sine of x is actually asking, it's asking what is the sine at that same angle, 120 degrees. And of course that answer is the y coordinate at 120 degrees, which is positive radical 3 over 2. So unit circle used for this entire page. And then the last page, what I would again encourage you to do, which some of you may have done this on your unit circle, is draw a quick sine chart. We know in the first quadrant, x and y are both positive, which means cosine and sine are both positive. Since tangent is y divided by x, tangent is also positive in this quadrant. The second quadrant, the x coordinate is negative, which means cosine is negative and sine is positive. Since tangent is y divided by x, tangent is negative in this quadrant. Quadrant 3, x and y are both negative. A negative divided by a negative is a positive, so that's why tangent is positive. And in our final quadrant, cosine is positive, sine is negative, which means tangent is negative in this quadrant as well. So then that's going to make answering questions 9 through 12 really fast. Number 9 says, which quadrants do cosine and tangent have the same sign? So basically, which quadrants are cosine and tangent either both positive in or both negative in? Well, quadrant 1, both cosine and tangent are both positive, so they have the same sign in quadrant number 1. And then I see quadrant number 2 works as well, because cosine is negative and tangent is negative, so they have the same sign there in quadrant number 2. Number 10, same type question, except this time they want to know which quadrant do sine and tangent have the same sign out front. So that is still quadrant 1 because sine is positive and tangent is positive. The other answer is where are they both negative, and that's quadrant number 4. Sine is negative and tangent is negative in quadrant 4. Number 11, cosine is negative. So where is x negative and sine positive? So x is negative and y is positive in quadrant number 2. Here are the 3 things we talked about that are true about a reference angle. You could have also said one of your things being it's the shortest distance or degree measured to the x-axis. I would have taken that as well. But that's how we're going to answer these last questions. And basically, these are the only questions you don't really use the unit circle for. So 140 degrees, that of course is in quadrant number 2. So I'm going to sketch 140. It's 90 plus 50 more. So with reference angles, I always like to fill in these little measurements. So if this piece is 90 and this piece is 50, the reference angle is the shortest distance to the x-axis. So that's this piece right here, which would have to be 40 degrees. .205 is in the 3rd quadrant. This piece is 90, this piece is 90, which means this piece is 25. 90, 90, and 25 give you 205. The reference angle is the shortest distance to the x-axis, so that's this piece right here. It's less than 90, it's positive, that's our reference angle. 355 is in the 4th quadrant, almost a full circle. So that's a 355 degree angle. We know that this piece right here, of course, is 5 degrees because this angle is 5 degrees short of becoming a full circle. So that is our reference angle, shortest distance to the x-axis. And then last one, negative 58. Remember, the reference angle is always positive, so be careful on this one. Negative 58 is going to go clockwise. This direction. But 58 is the reference angle. It's the shortest distance to the x-axis. You just have to make that negative 58 a positive. So that's our answer. And then finally, number 17, which of these does not have a reference angle of 30 degrees? Well, we know it's not A because 30 degrees is in the 1st quadrant and it's its own reference angle because it's already the shortest distance to the x-axis. If we check B, 210 degrees, that's in the 3rd quadrant. This piece is 90, this piece is 90, this piece is 30. 30 degrees is the shortest distance to the x-axis, so it's not 210. 120. .90, that piece is 30. The 30 here is not the reference angle because neither one of those sides is the x-axis. The reference angle in this case is this piece, which is 60 degrees. So which one of these does not have a reference angle of 30? It's 120.